a pretty classic example of movement that happens inside of Metroidvanias is some sort of sloped movement for the character. In Castlevania, it's going up and down stairs. In Samus, there's just terrain that has different slopes to it, or in Metroid. And so we're going to be doing that as well. Now, the way that I've decided to do this is to use Godot's built-in move and slide with snap function. And from what I can tell, this function seems to have a few little areas that aren't working quite as expected. And so at least what I've discussed with a few other Godot users. And so, but I've come up with some solutions to get around those. They're a little bit hacky, but I feel like the benefit of using that built-in function and then adding these, it's like 8 or 10 lines of code or something to deal with the problems that arise from it is worth it over writing my own platforming code from scratch. So let's get back into our player here. And we're going to adjust our character to use, well, first, actually, let's add a new static body to this world. There we go. Call it terrain. We'll give it a collision polygon. So collision polygon 2D. And then we can use this little plus button up here to create some terrain with this. So I'm just going to do maybe I'll come down lower like to here, add a little bit of a slope. Something like that. And you can draw yours however you want. However, I recommend having a 45-degree slope like this because we'll be testing for a slope at 45 degrees. And then also having a little jump at the end of this slope. And I'll show you why as we get into this. So we'll save that. Then come to debug and click visible collision shapes. This will allow us to see these collisions while we're moving around in the world. And you can see technically our character kind of can do slopes. We can move up slopes. However, if we're moving down slopes, our character kind of makes a little jump and then lands after. So the character doesn't snap to the slope. And we're going to be fixing that. Looks like maybe we can't. What? Oh, we can make it up here. Okay. So inside the player character right here, we're going to first switch our move and slide to use move and slide with snap. So the idea being this snaps our character to the ground. So as we move down a slope, we will no longer jump right at the top and then fall. We'll just automatically move down the slope like we're walking down it instead of having a little jump first. However, we need to pass some more information into this move and slide with snap function. The first being a snap vector. Vector 2 dot down. So we want to snap down times 4. So that will then be our snap vector. And the next thing we need to pass into it is, let's see, so we've got our velocity, our snap vector, our floor normal, stop on slopes. We want to set stop on slopes equal to true. Max slides, the default for this is 4, so we'll just use the default. And then we need a floor. This is basically a slope angle, like what's the maximum slope angle we can do. And we already set this up here. So we'll use degree to rad slope angle. And this is the reason we have to use this is because it takes a radian value, not a degree. And so we're converting our 46 degrees into whatever that is in radians. So then we can save and run the game here. And you can see we should now walk up and down slopes perfectly. But we can't jump. And that's because we are snapping to the ground. So we can't jump. Every time we try and jump, it snaps us right back to the ground. So how do you solve that problem? Well, it's not too hard. We just create a variable for our snap vector. Snap vector. We set this to vector2.0. And then when we jump, right here, jump check, we also set our snap vector. Snap vector equals vector 2.0. So we stop snapping. And then then we need to also update our snap vector if we are on the ground so that it actually snaps. So we'll make a function for that, and we'll put it right before our jump check. So after apply friction, update snap vector. We'll just say if is on floor, snap vector equals vector 2.down. And then down here, instead of doing vector 2.down, just do snap vector. So how does this work? When we're in the air, our snap vector, if we press the jump button, our snap vector gets set to 0, so we no longer snap. If we're on the ground, our snap vector gets set to down times 4. And so then we snap down 4 pixels below us, in theory. The other benefit of this is, remember how we had to apply gravity all the time? Well, now we can set it to only apply gravity when we're on the ground, so we can uncomment that section. Well, we're getting some weird stuff going on here. And it's probably because we forgot to actually, once again, the classic, forgot to call the function that we wrote. Update snap vector. Oh goodness, there we go. So call that before the jump check. There we go. Now we're talking. Now our character snaps to the ground, but we can also jump. Now there's problems with this, and I'll show you what they are. The first problem is that if we stop on a hill, we slowly slide down. If you remember, we set our stop on slope to true. But what I have discovered is that stop on slope actually works. And the snap vector actually works. However, when they're both being done together, stop on slope doesn't work. And my best guess is, from the testing and stuff that I've done, the snap vector is attempting to snap the character to the ground, and it pushes the character down. So even when stop on slope is true, we still get this sliding right here, this sliding effect. The other issue is if you jump onto the hill like this, you stop for a second before you start going up. And it can look a little bit jarring. And the final issue is if you go up a slope, if we actually look at our character here, over here in remote, okay, so this is getting a little bit into debugging here. So you can click over here, click remote, and click on the player, and we can actually see the properties of our player over here. This is live because we clicked on remote. Local here isn't live, but if you click on remote, it'll give you the live properties of your player. So we can see my player here, and we can see the properties of this player. You can see that there is a y motion of -64. That's because as we're moving up this slope, move and slide gives us a y value, right? And normally that would make us jump into the air a little bit, right? But because we're snapping to the ground, it keeps us from doing that. However, the snap to the ground apparently doesn't detect that we should no longer be moving. And I can understand why this might be, but it doesn't know that we're no longer going up a slope, so it keeps that y value. It keeps snapping us to the ground so we don't pop into the air, but then we never actually hit the ground, so our y value doesn't get set back to 0. And so it's a little bit weird. You can see if I come over here, no matter what I do, we still get this y value. And if I run off this cliff, oh, there it pops up a little bit. It applies the y value there instead, because this distance is too large to snap. And so we get this little hop at the end. So I have fixes for all of these problems, and we'll get into them into the next lecture. Thank you guys so much for watching. I will see you all in the next lecture.